everyone, we're going to find the length of the arc with our parametric equations over the interval 0 to pi divided by 3. We're going to use this formula to find the length. So first we have to differentiate our x and our y. So for our x, when you differentiate this whole thing, there shouldn't be a parentheses there, but anyway, we're going to get 1 divided by secant of t plus tan of t, and now we have to differentiate our secant t plus tan of t. So the derivative of secant of t is secant t times tan of t, and the derivative of tan of t is going to be secant squared. So that's going to be plus secant squared of t. And then for your sine, that's going to just be minus cosine of t for your derivative. So we simplify this, we get x prime equals, pull out your secant of t in the numerator, and you're going to get tan of t plus secant of t divided by secant of t plus tan of t. All right, that cancels out. We still have this minus cosine of t. Now for your, so basically it's secant t minus cosine of t. For your y, that's just going to be negative sine of t. So let's start substituting in our formula. Our length is going to go from 0 to pi divided by 3. And we have secant of t minus cosine of t squared plus negative sine of t squared, and this whole thing is a square root. All right, now I'm going to squeeze this in. This part right here is going to be the square root of secant squared of t minus 2 secant t cosine of t plus cosine of t squared plus sine of t squared. And this is all dt, by the way, dt. All right, now before I move on, this is dt. Before I move on, I want us to notice something. This right here is your Pythagorean identity. This equals 1. Also, secant times cosine equals 1. So basically what we're going to have is secant squared minus 2 plus 1. So let's write that down. We're going to have the integral from 0 to pi divided by 3. And we had the secant squared of t minus 2 plus 1 dt. This is just going to equal negative 1. Therefore, your integral now is going to be from 0 to pi divided by 3. And secant squared of t minus 1 equals tan squared of t dt. All right, now, when you square root a square, you're still going to get this equals the integral from 0 to pi divided by 2. This is just going to be tan of t dt. All right, so evaluating this, the integral of tan of t is negative ln of absolute value of cosine of t. And then we're evaluating this from 0 to pi divided by 3. All right, so when you substitute this in, we're going to get negative ln of cosine of pi divided by 3 minus negative ln of cosine of 0. So cosine of pi divided by 3 is 1/2. Minus cosine of 0 is 1, but ln of 1 is 0. So that's just going to zero out. we have our answer is negative ln of 1/2. Using your properties of logs, I can move this negative here. So that is going to simplify to your length is ln of 2 using your properties of exponents. And that is your answer. Thank you. Have a nice day. Bye-bye.
Yeah. Weezy,